Hello everyone. So in this video, we will learn about how we can do a one sample proportion test. So if there is a said proportion and if you want to check from the data that the null hypothesis is accepted or rejected, we can easily do that using R. So to do that again, let me share the screen with you and go to R. So first of all, the first problem of this is out of 156 participants in a study, 40 students mentioned that they update their Facebook status at least daily. So can we conclude that the proportion is not 0.30? So the proportion that has been given is not equal to 0.30. So in this example, the null hypothesis, if we write the null hypothesis H0, this is equal to P equal to 0.30, and the alternative of this should be P equal to, or rather it should be P is not equal to, I can write any 0.30, because it says the population proportion is not 0.30. So to perform this kind of an hypothesis test in R, we can use the function prop.test. So this is a basic function which can be found in R. So we can use the prop.test function. The first argument that is asked for is X, that is how many success or how many failures that we had. So in this example, there were 48 success. Out of the total number of participants that we had, the total number of participants were 156. So we have 48 success, 156 for the number of participants. Now we have the true value or what we are testing against. So we are testing against the null hypothesis of P equal to 0.30, and the alternative hypothesis over here was H1 is not equal to, so this should be P, H1 versus that P is not equal to 0.30. So the alternative of this should be equal to two-sided. So we should write two dot sided and this should go under quotation marks. Now if we hit run, we get the sample estimate. So this is your P hat, the sample estimate, this is your P hat. We have, so it over is clearly stated that the alternative hypothesis true P is not equal to 0.3. We have a p-value of 0.9027. So if we compare that with any alpha of 5%, 1%, or even 10%, we fail to reject the null hypothesis. So the p-value is very high over here, which is greater than alpha. So we fail to reject the null hypothesis. And by default, it gives us a 95% confidence interval. So in this case, the 95% confidence interval lies between the value of 0.237, so 0.2376 and 0.3873. Now, suppose the question is asking not for a 95%. So if we just write this code, it gives a by default value of a 95% confidence interval. However, according to the need of the question, I can change this confidence interval. I can change it to a 99%, or even I can change it to 90%, or whatever the question is asking for. So this is what we get by default. So the default is 95% confidence interval. However, if I want to have a 90% confidence interval, to do that everything remains the same. So I will copy this, the proportion.test. The only thing that changes over here is the value of your prop. So to do that, I will use a statement or an argument called as conf.level. So the conf.level, this assigns what percentage of confidence interval we're looking for. For 90%, this should be 0.90. So if we hit enter, you can check that everything remains the same. The proportion remains the same, the p-value remains the same, the alternative hypothesis remains the same. Only thing that changes is the confidence interval. So this is from 0.2476 and this is 0.3764. Also, we can also find a 95% confidence interval. So if I copy all of them and I want to find a 99% confidence interval right now, what I can do is I can only change this value of conf dot level to from 0.90 to 0.99, and if I hit enter, it gives a value of a 99% confidence interval. So this says in the last part, it says 99% confidence interval. Now if I make this a little bit larger, this console, there's an interesting thing that you can find. As the confidence level increases, so we have 95 percentage, we have 90 percentage, and we have 99 percentage. So as the confidence level increases of any confidence interval, the width of the confidence interval is also increasing. So for 90%, the width is minimum. For 99%, the width of the confidence interval is the most. So as the confidence level increases, the width of the confidence interval also increases. Now, one more example that I want to share with you is that in 1999, 5.8% of job applicants failed the drug test. At 0.01 level of significance, test the claim that the failure rate is now lower if a simple random sample of 15-20 job applicants results in 58 failures. Also, in this example, we need to construct a 99% confidence interval. So from the beginning, what is our null hypothesis? So our H naught for this example is P is equal to, so this is given in 5.8%, so we should write it in decimal point. So this should be 0.058. What is the alternative hypothesis? So the alternative hypothesis should be P, and since we are looking for that the failure rate is now lower, so P should be less than 0.058. Okay. Next, what is the value of alpha? Against what we need to compare? So the level of significance alpha over here is 0.01. Now, since we know this and also we know the number of success and the total number of observations, so we can use the prop dot test. So using the prop dot test over here, x, that is the first argument, represents the number of success or the number of failures. So in this example, we have 58 failures. The total number of observations is 1520. We are testing against a P of 0.058, and we want to do a confidence level of 99% because we want to construct a 99% confidence interval. So confidence level equal to 0.99, and we have the alternative hypothesis. So the one alternative hypothesis over here is less than. So we can write this to be alternative. This is equal to less. Remember, whenever you're writing less or greater or two-sided, you should always place that under quotation marks. Now, if I run this, we have the p-value, we have the 99% confidence interval, and also we have the value of your p hat. The sample estimate is a value of your p hat. So the p hat value is 0.038. We have the p-value to be 0.00567. So this number is much small than the level of significance alpha of 0.01. So for this example, we reject null hypothesis. So we have sufficient claim that the number of applicants has reduced than in 1999, reduced from 5.8% than in 1999. Also, the 99% confidence interval, it ranges from the value of 0 all the way to the value of 0.52, 0.052. So, in today's video, we learned about proportion test, a one sample proportion test. How can we construct different levels of confidence interval, and based on the alternative hypothesis, how we can construct a one-sided or a two-sided hypothesis test. Okay. So that's all what we have for today. Thank you.